How do you do, ladies and gentlemen, and boys and girls? I am Julius Sumner Miller, and physics is my business. And our very special business today is the subject of simple machines. Simple machines. Now, when you study these matters in school, it is usually said that these are the 6 simple machines. The lever, or as some pronounce it, the lever, the inclined plane, the wheel and axle, the screw, the wedge, and the pulley. And I wish in this program to show that really all of these reduce to only 2, the lever and the inclined plane. And what is better for us to contemplate is the following, that all of the things I will have to deal with here today are the most plebeian and simple and homely and commonplace. And my purpose is essentially this, that when you pick up your fork and knife to eat your dinner, I hope you would recognize that you are using some levers. Indeed, the sharpened blade of the knife is an inclined plane in addition to the tool itself being a lever or lever. And how about the prongs of the fork? The prongs of the fork are usually sharpened a little bit, so they are wedges, and wedges are inclined planes. So let us go at random to some of the things we have here, and you will see exactly what I mean. Consider, for example, the following. Here is a block of wood in which I have already lodged some bolts and screws and other things. Here is a screw, and I'm going to attempt to lodge it further into the wood with a tiny screwdriver. A tiny screwdriver. No success. Why? Well, let us look at what really happens. The handle of the screwdriver I have enlarged, looks like that, and I apply a force this way and a force that way so that I turn it about a central axis, and these 2 forces, equal and oppositely directed and parallel, are said to be a couple, C-O-U-P-L-E. You see a couple of forces acting in this way. Now, the small screwdriver had too small a radius. So what do? I use a big screwdriver, and the same force will accomplish my purpose very readily, as you will see. Here is a big one. And the handle, of course, is very much bigger, so that the torque, or the turning effect of my force, is very much increased. There it is, beautifully accomplished. Consider now, I remark that a threaded cylinder, which we call a screw, is really an inclined plane. And I hope you see the inclined planeness in this threaded shaft. I'm going to prove to you that it's an inclined plane. Here I have an inclined plane cut out of paper, and it goes uphill to my left. I'm going to wrap this around a cylinder, and I hope you see that what I will get out of it is this. Here is the cylinder, and I wrap the inclined plane around, and I get a threaded shaft, which is a screw. Now watch this. Here, I'm going to wrap it around. Let me finish it here first. And there you will see the inclined threads. Now, I have wrapped this one around so that the threads go like that, which is a left-handed screw. I have cut the other one so that when I wrap it around, it gives me, I hope, yes, let me turn it over. No, there. Notice I'm a little twisted up here. Well, notice I'm glad I'm twisted up, because this suggests that even professors of physics can get a little bewildered. I know where I made the mistake. One of these I have to turn over and use the mirror image, and then it will give me a right-handed screw. Now, this business of left-handed thread and right-handed thread, very important. Illustration. Oxygen tanks used to take care of sick people are right-handed threaded. Nitrogen tanks, on the other hand, I believe, are left-handed threaded, for the very reason that then nitrogen could not be inadvertently and accidentally fed to a patient who should be getting oxygen. See, very important idea. Let's look at another one. Here is a bottle with a screw cap, and the housewife finds that she cannot undo it because it is too firmly fixed. What does she do? Answer. Provide herself with a lever. and a notched jaw, which is essentially an inclined plane. And then she puts it on there, and ever so gently, there it is. So I say that for little bottles with small screw caps, you have a small Stillson wrench, and for medium bottles, a bigger Stillson wrench, and for very big bottles, a very big Stillson wrench. And any well-equipped household, I think, should have at least 3 Stillson wrenches. Consider, for the housewives and the boys and girls and the teachers, here is a grater. Now, what is a grater? A grater, well, a grater, you grate with a grater. There it is. And I say a grater is an inclined plane. Very clearly an inclined plane. How about a wedge? A wedge. A wedge is clearly an inclined plane. Consider the following. Here is a railroad spike. Indeed, it is pointed, quite like nails are pointed. Why? They are inclined planes, and the advance into the railroad tie is more easily accomplished because this is an inclined plane. Let's go to an ordinary hammer. Here is a nail that I've lodged in here. A lot to say about this. Let me use the hammer as a lever. Not much success. I improve its mechanical advantage by providing a block under the head, and there. And now what must I say? What must I say? Very important. What do I feel when I feel this nail? Very hot. Friction develops heat, and friction is a dissipative force, always arising when work is done, and about which we spend fortunes to eliminate. Very important. But remember, if we could accomplish the elimination of friction, no motion whatsoever would be possible. A very terrible thing to contemplate. Here I have another one in front of me. How about a nutcracker, a lever? What happens? I put the nut in here, and then easily accomplished, effortlessly. Here's one for the housewives and the boys and girls and the mothers and fathers and the school teachers. A broom. A broom, I regret to say, is a lever. And next time you sweep the house, I wish you would have some regard for Archimedes of the 3rd century B.C. And I'm going to show you how the lever can be used in an enchanting way. The usual way is what? We hold it there and push here, push here, push here. The fulcrum here and the force there and the load down there. It can be used in another way. Watch me. I'm going to have the fulcrum here, and I'm going to push it here. Not too handsome a way to use a broom, but it can be used as another class lever. More on the same. If indeed the subject is getting, let us say, monotonous, it should not be. All these things are levers. Here is a piece of metal. Here a little pair of metal clippers. I have difficulty. Why? Not enough lever arm. Not enough lever arm. A larger shears, effortlessly. There it is, like cutting butter. Or consider a file. What is a file? A file is a succession of inclined planes. And regarding a file, I hope sometime you will be able to go to Milan, Italy. And in the Museum de Leonardo da Vinci, there are many of Leonardo's devices, and one of them is his file maker. And when I was there last, I used it and made, indeed, some scratches on a file. How about a meat grinder? Oh, nobody uses a meat grinder much these days because it's done for you. But if you will look inside, you will see that that is an inclined plane. Beautiful there. The camera catches it nicely. Here it is. Here's one of the cutting tools from inside, and you see it is an inclined plane. How about an egg beater? An egg beater. An egg beater is not a simple machine. An egg beater is a compound machine made up of a lever, the handle, and some geared wheels. And what do? We turn the geared wheel. There is a certain number of notches on the big wheel and a certain number there. The handle is so long, and so we speak of the mechanical advantage of a simple machine. Meaning what? How many times is the force multiplied when we apply a force? If, for example, with a force of 1 pound I can lift a ton, then the mechanical advantage is 2,000. Let me go further. Here is an interesting thing. Pulleys. Pulleys. Now it is very important that I say something about pulleys. When students and boys and girls study pulleys, it is usually said that to find the mechanical advantage of a pulley system, you count the number of ropes supporting the load. Now, I should say that this is not a good thing to do. It sometimes leads to the right answer, but often the right answer is gotten by physically wrong means. And this is a very important philosophy to remember. Getting the right answer is the least important of your endeavors. What must be right is the logical, analytical reasoning that leads to it. So I would urge you to study pulleys and learn how to find the mechanical advantage without counting the number of ropes. Here is a pulley system made up of 2 blocks with 3 sheaves each, or 3 pulleys each rather, and I can lift an enormous force by the application of a small one. Notice, friction is not playing an adequate role, and so the system unwinds. And when I talk about pulleys, what name in history must come to my mind? Answer, Archimedes, because you remember he designed all kinds of machines of war in order to protect the city of Syracuse against the invasion by the Romans. And I would urge you to read the story of this great adventure as recorded by Plutarch, The Siege of Syracuse by Marcellus, the Roman general. Where am I now? Where am I? Oh, let us take some ordinary cutting pliers. What is a cutting plier? Well, we say it in the plural, pliers, wire cutters. First, it's a lever. Secondly, it's an inclined plane because the cutting jaws are inclined for sharpness. And ever so effortlessly, I cut a wire. And so, ladies and gentlemen, and boys and girls, we come to the end of this program, indeed to the end of this 15th program, and what has been my singular ambition throughout the series. It has been just this: not to teach you any physics, not to assign any lessons or any problems, but rather to point up the beauty and the drama in all of this and to excite your enthusiasm and your curiosity, for these are the foundations which will lead to your better understanding. Now, what have we done? What do physicists do? What is physics? What is science? That's an all-embracive term. Science, of course, is what scientists do. Physics is what physicists do. And what do physicists do? Physicists explore how nature behaves. And I urge you to spell that nature with a capital N. So as you go about your daily affairs, your school days, your days at home, your playing hours, I would urge you to have a regard for the things all around you, for they are filled with beauty and drama. And seeing how nature behaves will give you a full life. And I thank you for listening.